Yeah, there we go.
Like, how many points would you knock off for?
We're rolling.
So we're gonna have a test next week?
Pardon?
Are we gonna have a test next week?
You want it next week?
No.
No.
There's,
I
well,
mean,
okay,
we know.
question, we have a choice, because there's 3 more tests.
Because we got the concept, 4-5 concept, and then 4-5 application due on Monday. Concept due tomorrow.
Oh, wait, concepts due Tuesday.
we're running out of time.
Yeah.
Yeah, I see what I mean.
So next Wednesday?
I think that's reasonable.
You don't think that's reasonable?
No, I didn't.
Next
Oh, you do?
Wednesday,
Yeah.
the 25th,
Yeah.
for test.
We're gonna have to, we don't have a
Yeah.
choice.
Oh.
Let me write that down.
No.
That's all.
Group chat back if the test
Well,
was
we
this
will-
Monday, I'm like, we're so.
Force diagrams, facades.
That's okay.
Now we have
Okay,
the contracts
that's
again.
just the force diagrams and the facade stuff though.
No, not just that. There's gonna be Newton's laws of motion. There's gonna
It was
be.
part of facades.
I know, but
So the 25th, we have a test.
25th, test 1B, tears, actual tears.
Great.
Hold on.
It's like banging a head against the wall. Feels so much better when you stop.
I don't know about that.
actual theory. I have to pull up all-nighter exam on Sunday.
Any questions?
Can you just elaborate one more time? I know you've done it like 5 times already. Can you just elaborate one more time on like, if we were to get this grade on a test and we do test corrections,
Oh, yeah.
what's the maximum?
All right.
I'm sorry, I know you.
The way
did
test
it.
corrections work. We're on first grade. And then best possible with corrections.
No. We would have a lot more.
So
And then all of the 2 hours of last week.
if it's a minus, you subtract 0.3, so A minus would be 3.7, B minus would be 2.7, and so forth.
Okay.
If it's a plus, then you add 0.3. So if you got a A on it, you can bring it up to an A plus. You got an F on it, you can bring it up to a 2.
Oh my god. Okay.
So that sets the scale. So 2 is halfway between 0 and 4. That's an A. So halfway between that is 3.15.
If you get a 3,
Okay.
if you get a 3, what, how much can you bring up your score by?
It's halfway between those.
If you got a 0, would that mean you like didn't get anything right, or that's just an F?
That's an F.
That's an F, and then you'd be able to get it to a 2, which would be like a
C.
C.
Okay.
Okay.
4 point.
So that's assuming you got all the test corrections correct.
Yes.
Okay. Wow.
3.73.
3.73?
So
Like an
that
A
would be
minus?
considered an
A minus.
Yeah, so if, let's say that you got a B on it, you did all the test corrections, you convinced me that you understand what you missed, and everything's beautiful, I'm going, oh, if only this person had done it that way the first time. So you get the 3.73 or whatever the number actually is, assuming if Robin typed it in correctly, then that's what would show up in the grade book, 3.73. I don't round it at that point.
And then, what do you call this? It's a 2, so 2.7 is a C
B.
plus, right?
No, 2.7 is a B minus.
And then you can raise it up to a 3.73 regardless.
If you got a 2.7, you can bring it up to whatever it is, 70% of the way from here to here.
I don't know if you've explained it, but the way you do grades, does that account for like the weights of stuff, or do you also put like weights of stuff on top of your grades?
The weighting,
Yeah.
So in the end, you've got basically quiz grades, lab grades, test grades. So I find the average of each of those three types. Test grades will count twice, and then I'll take between labs, test, and quiz average, I'll take the middle one and throw that in there. And so those are the 5 numbers I'll average in the end.
Okay.
And it stems from a student years ago going, we spend so much time on the labs, but they're really not worth much, which they weren't at the time. And I thought that was a fair assessment. And so I shifted it around so that it gave more weight. Now, my original idea, I can't remember if I mentioned this before, my original idea is to take those 3 types, throw out the highest of the 3, and then average the remaining 2. And that was universally disliked
Yeah.
by faculty and students, and my wife.
What was your thought process?
What my thought process was, if let's say you got the 3 grades, I want people to work hard. So if the highest average doesn't count and it's based upon the 2 lowest ones, that would force them to work hard in order to get the higher grade.
I mean, they could have, you figured it out anyway, there's no use in the discussion.
Yep, no, they did. Someday I'll subjectively do it.
So theoretically, if you do really well on labs and master sets, and you do not great on a test, but you wouldn't necessarily like plummet here, right?
No, my system is set up so that if you're having just a really bad day, your grade is not sunk.
Okay.
I had a student when I was teaching at CPCC who showed up, man, that was a heck of a semester for her. Her husband came home after being in the military. Husband left her. Day of the last test, she came in looking like death walked over. Not because she was sick. She didn't even finish the test. So I tried to set up a system so that, that really crappy day she had, well, she probably had at least 2 really crappy days that I saw, was designed so it didn't sink her. I did not have the system in place at that point, but.
That makes me feel a little better.
And also, no matter what, the grading systems are flawed. So if you've got a 2.4 average, that officially is a C, but I'm going, okay, is the class better off with that person being here? Has that person done anything? In reality, has that person taken me off for any reason? That's cheating, asking about whether lawyers or physicists are better in the middle of class when we're talking about something else, that kind of thing. Doing test corrections in red ink on the original test.
Really didn't like that guy.
Something just wasn't quite right. He didn't cheat though, the cheating was a reference to the persecution of the
Do you have a lot of cheaters that try to cheat on?
Not that I've noticed, there are some that there's one who was using his phone as a calculator, and I noticed some odd behavior, so I walked back there, and he immediately had that scared look in his eye, and what was on his phone with the answers.
Oh.
And so I asked him to step out into the hallway. We had a chat. I like the guy. I feel bad being in a drama.
So he wasn't electrocuted or hit with any physics demonstration object?
No, I saved that for Jose.
Middle school.
Middle school.
Middle schoolers, yes.
Okay.
That'll teach them. You haven't gotten to the chapter 7 master set, chapter 8 master set, the one where I talk about the gym coach throwing a basketball at a student. Those were the days. That's how I was raised.
Suicide.
We didn't throw the ball at me. I just wasn't paying attention. The people who were talking saw the basketball being thrown and stepped out of the way. I got hit. Anyway, I digress. Other questions?
Quick question.
Rob?
So on the master set, there's an elevator question,
Yep.
and then we have a pulley, right? Is there gravity being exerted on the the pulley itself that we have
What-
to?
What's the which elevator question?
Yeah, number 4, this one. So do we need to put like a weight symbol on the pulley itself? Because,
Did I see the original problem? Do you have it up?
yep.
Number 4, elevator is being lifted in the shaft, constant speed by steel cable, frictional effects are negligible, describe the forces on the just the elevator, just the box, not the pulley.
Okay, box rising. And then what's the relationship between the velocity and the acceleration of yourself while you're in like a scale? Because that's one of the questions here. It said like, rank the figures from greatest to least on the basis of a scale reading, where there's like a different velocity and acceleration for each moment.
Scale. Person. Ground.
Yes.
Or whatever it's sitting on.
Yeah.
What are the forces acting on the person?
Weight. Normal force up. That's it.
And the scale?
Weight up.
Way
Wait.
down.
Really? Oh yeah.
Weight of scale, we put the ground down here, we got a weight of the person there, and weight of the scale there.
And then normal force downward as well
From,
from the scale.
what's causing that normal force down?
Person.
There's a normal force acting up and a normal force acting down on the scale.
Oh.
But-
So there's a normal force acting down from the person, and then there's a normal force acting up from the ground.
All right, so we've got these 3 forces acting on the scale. What does the scale actually measure?
Your
Yeah.
Yes.
The only force that the person exerts on the scale is that. So, which is equivalent to that in magnitude. So, in terms of the scale reading, if you're accelerating upwards, which of these 2 forces is bigger?
the normal force. If you're accelerating up.
Yeah, if you're
normal
accelerating
force.
up.
The normal force.
If you're accelerating downwards, which,
The weight.
okay. If you're moving up, but your acceleration is down,
Wait.
yes. Are you saying the word W-A-I-T or W-E-I-G-H-T?
WEIGH.
Yeah. The direction that you're actually moving is irrelevant. Matters is the acceleration. I feel like your question was unanswered, despite the absolute brilliance of.
It probably made sense, but it just didn't click in for me. So, the direction of your acceleration does not matter?
The what?
The direction of your acceleration does not really
Oh, no,
matter?
it matters a great deal. The direction of your velocity doesn't matter. You're asked to rank the scale readings,
Yeah, for part A.
so let's assume up is positive. If up is positive, then I have yp minus weight of the person is equal to mass times acceleration.
Yeah.
Yp is equal to Wp plus Ma. Your weight's not changing,
Uh-huh.
your mass is not changing.
Yeah.
So there's some relationship between what the scale reads and your acceleration.
Oh, that's why you said velocity does not really matter.
Right.
So like the faster the acceleration is going downward, the higher your normal force is? Is that correct?
If your acceleration is down, I said up was positive,
Oh.
your acceleration is downwards, this is a negative value.
Yeah.
So you'll have some positive value minus something, so
Okay.
it'll get smaller.
So that it just depends on what direction we set for the question?
In terms of positive or negative?
Yeah,
No, ultimately, we care about the magnitude of this.
okay,
So if you said down was positive, then this is some negative number. But what really matters in terms of what the scale reads, it's the magnitude.
okay.
Other questions? Or same question? All right. Let's talk about, we've done the car going around in the circle, so let's. So I have a mass that's swinging around in a horizontal circle. What I want to know is, well, let's just explore. So if I'm going through the process here of solving, even though I haven't, actually let's find the, how much time will it take the mass to go around? Just do it in terms of unknowns, we can see numbers in later, but I want to find the period. Period is how, for something that's happening in repetitive motion, period is the time to do one cycle of that. So this is period. The reason I don't use capital T for tension. Now, there's various steps we need to go through, obviously facades. So let's start out with the force diagram. What I really care about are the forces acting on the mass. So what forces are acting on that mass?
Wait,
No.
tension.
Is that it?
Yeah.
Okay. So we have those two forces acting on it. A, acceleration. What is the direction of acceleration?
Probably from left to right?
From, you mean, right? That way?
Yeah.
Okay. Everyone good with that? Latika, did you say something?
Towards the center of the circle.
Oh, yeah.
Yeah, it is towards the center of the circle, which is that way?
Yeah.
Yeah, it is. It's traveling in a horizontal circle. So towards the center, at this point right here, if that's at the leftmost extreme, would be pointed that way. When it's here, it's pointed that way. It's basically pointing towards the center the entire time. So we set up our acceleration is in that direction at this point. So we set up our coordinate system as such. And decomposition.
Tension will have to be
Yeah.
Why?
because it is made up of an angle, well, it's in a direction that's in between phi hat and j hat, so it's a combination of both.
Yep, all right. So I do know that this angle here is theta, which tells me that this angle here is also theta. Because this angle theta, the first one I gave is versus the horizontal. I just draw a virtual horizontal line here, which is basically the path that, or the plane that the mass is traveling in. And I have two pairs, so these two are parallel, cut by transverse, alternate interior angles are congruent. So I know that this angle here is theta. even though this is a force diagram, this is a physical diagram, the angles are still the same, because the tension is along the direction of the line. So, what's the horizontal component of the tension?
FT cos
Cosine
theta.
theta.
So I got weight acting down, I have Ft cos theta going this way, and what's up?
Tension sine theta upward.
Okay. Equations of motion?
For I hat, it's going to be tension times cosine theta equals mass times acceleration.
Why do you put a subscript C next to the A?
Because it's centripetal,
Okay? How do you know it's centripetal?
because it's moving in a circular motion.
All right, and my other equation?
For positive j hat, it's tension times sine theta minus weight equals 0,
Why 0?
because it's, hold on, I had the answer, but I forgot. So, do it that way. Wait,
Cause there's no acceleration in the
yeah, why?
vertical direction.
Say it again?
There's no acceleration in the vertical direction.
Right, yeah,
That's it.
you're right, it is 0.
Yeah, but like,
It's technically mass times the acceleration
Yeah.
vertically, which is 0.
but if it's going around,
It's going around.
oh, it goes around this way.
Horizontal.
If it went vertical like that, our vertical,
Yeah,
our
that-
I hat would be 0.
Actually, if it's going around like this, then we'd definitely have to pinpoint a spot where it is, because weight is constantly acting down, tension is acting this way. So the tension would be changing because it's probably at a constant speed.
Okay, but for most of our problems, it'll just be like horizontal.
Yeah.
Okay.
All right, so I have my two equations here. Substitution. For what do I have an independent equation?
Weight
Weight.
equals mass times acceleration.
Weight equals mass times.
Gravitation.
Gravitation. No.
G.
I think